to determine the reactions of the above beam using the three-moment equation. So right down here, I've given you the three-moment equation. Okay, this is the general form of the three-moment equation. If you want to, there's other forms that have been derived in order to use, for example, if the moment of inertia of the beam is constant, and there's a slightly more simplified version that you can use. But I like using this formula because it works for every situation when you're using the three-moment equation method, and I find it to be safer. But okay, so what is the first step in a three-moment equation question? Well, first question, pretty much with any indeterminate problem, is to count the number of reactions. So we have 4 reactions, okay? We have pin, roller, roller, and we have 3 equations. Therefore, we have a first degree indeterminacy. Okay, so first degree indeterminate. So we're going to need to eliminate one of these reactions or make one of the reactions redundant in some way in order to continue. So that's what we're going to work with. So first step is to select the redundant support, and our redundant support here is simply going to be B. So we're going to select the support in the middle so that we have a support on the left and we have a support on the right, and then we can continue. Okay, because as you'll see in the three-moment equation that's on the screen, you have ML and then MC, which means M is center, and then MR, okay? So this is MC in the center, and then, don't get that confused with MC when we use it as this notation, but MC for the general equation means the center. So you're going to select a support in between 2 supports, okay? So let's go ahead and let's start. So starting with we'll just fill out the three-moment equation, and I'm going to give you some, just some pointers, okay? So let's start. We have MA, okay, so ML, right? So the left, so when it says ML, it means the moment to the left, so the support to the left of B, which is A. Okay, so we have MA times the length, 8 times 3, which is 24. We're working with feet here, divided by 2I, okay? Don't make this mistake. This is the first trick. Watch for beams that are not prismatic, that don't have the same moment of inertia, because that's a very common trick that they're going to use. And even if you're just not paying attention, if you're not focused, you can forget to write this 2 here, and it's all over for you for that question. That's a 0. Okay, so moving on, we have the center term on the left side of the three-moment equation. Okay, so that's 2 times MB, okay, because MB is our center moment here. And we have 24, the length to the left, divided by 2I, okay, plus 20 divided by I, right? So the length to the right divided by the moment of inertia. And finally, we have the moment to the right, okay, so the right support, which is C, okay, so we have MC times the distance to that support, which is 20, divided by I, okay? Perfect, so we've just filled out the left side of the equation. Nice and simple. Let's work on the right side. So as you'll see, we have 2 terms. We have the sigma P times L squared times K divided by I, all right? And that is the formula for a point load, okay? So it's the summation, and you'll notice the summation sign because you have to do each point load, and you have to apply that term to each point load, okay? So let's start with that first, and it's a negative, okay? So let's start with the 30K. So we have 30, right, as in 30 kip, times the distance, the whole distance, okay? So that's going to be 24, and that's going to be squared according to the formula. And we have K, okay? So this is where we get to our second trick. So K, so remember, at the start of the question, we started as our redundant support being B, okay? And we're looking at the left is A and the right is C. So when they ask for KL, what that means is it's the ratio of the distance from A, not from B, from A to the force that we're working on, divided by the whole length between A and B. So if you were to take this 16 divided by 24, that would be wrong. And that's what I noticed a lot of people did on the test, okay? So if the redundant support is B, go over to A, okay, the left side, and then look at the distance from A to the force that we're working with, which is 8. Divide that by the whole distance, which is 24. We're going to get 0.333, which is 1 over 3. So that is our K. Okay, and that's like as tricky as it gets, guys. You just have to make sure not to make stupid calculation mistakes. But other than that, that's about as hard as it gets. Okay, make sure we carry the 2 with the I here. And we just have this term here, which is 1 minus K squared. So it's the same K that we found. The K to the left. Perfect. Let's do the second force. Okay, so 20. Just fill it in exactly like we did there. 24 again is squared. Okay, now this time K is going to be, remember, we'll go over to A and then we take the distance. So now we have 16 divided by 24. Okay, which is 0.66, so 2 over 3. Okay, and that is going to be divided again by 2I. we have our 1 minus k squared. K this time is 2 over 3. Perfect. Now, finally, we need to take a look at the WL cubed over 4i equation. Okay, so that's going to be minus, and that is referring to the right side. So we have a distributed load of 2.5 kip feet. That's in the right unit, so we'll leave it like that. Make sure your units are correct. We have the length to the right, which is 20. That's cubed. And I is just I times 4. Perfect. Okay, so, all you need to do now is work out this equation. But now you might be thinking, well, how do I do this? Because I have three unknowns, A, MA, MB, and MC. But this is the kind of the beauty of the three-moment equation, is that if we know from just basic structural analysis courses that we took before, if we have a roller or a pin support on the end like this, okay, not B, because we know B, there will be a negative moment developed here. Even though it's a roller, there will still be a negative moment. Is that at A and C, the moment is 0, okay? So, and so at A and C, the moment are going to be 0. So we can say that MA and MC are 0 in this case, and we're left with one moment term here, MB, one unknown. And all you need to do is just work this out. Okay, all the i's are going to end up canceling in the end, actually. So, you can just kind of start canceling these out, okay? Etc. Because they're constant and they're in every single term. Go ahead and work that out. Be careful, okay? So what you are going to get is that MB, okay, is equal to negative 151.5 kip feet, okay? After working this out, solving for MB. I'm not going to solve it for you. You guys know how to do that. But just do it on your own. Don't wait till the test. You might realize there's a couple little tricks in here, something that you weren't sure about or you weren't confident, so do that. And yeah, that's pretty much it, okay? So we're probably going to break this up into 2 videos, all right? And I'm going to show you in the next video how to apply MB in order to find the reactions at A, B, and C. Okay? Thanks for watching, guys.